Now, there's another set of identities that we term as the sum and difference formulas, where we're going to take the sum and difference of two angles. One I have represented that we're going to begin with is the difference of two cosine angles, where I have some cosine of an alpha minus a beta. Well, its identity is equated to the cosine of alpha times the cosine of beta plus sine alpha plus sine beta. Now, what we'll be looking at is basically if we were to draw or look at some triangle. I have right now the beginning of the proof that we're not going to explore fully, but the beginning of the proof, we're looking at this angle that's the difference between the larger angle and the smaller angle. The difference between the larger angle alpha and the smaller angle beta, the in between or what's left is the difference, alpha minus beta. So we're going to begin and we're going to accept this identity to be true. We've had many smart people that already verified it. If you get bored on your own, feel free to verify it on yourself. But right now you can take my word for it that it's a true model that we have right now. So we're going to look at the difference of our cosine angles through a couple of examples. So what is the exact value of the cosine of 15 degrees? Can we use that with this particular identity? Yes, we can go ahead and plug that into the black box and we get an approximation for the cosine of 15 degrees. Yeah, anybody can do that, but can we do it built upon some of the intellectual property that we've been building for ourselves? And I think we can. So what does this identity say? Well, let's rewrite cosine of 15 as a difference of two angles. Let's write it as the cosine of two angles that we know. And we know 60 and we know 45. Those are some of the standard angles that we've been practicing and starting to become comfortable with. So if we know 60 and 45, we know 15 based on this double angle or this difference angle identity that we have. So what does that look like? Well, you use identity, which says first a cosine of 60 degrees times the cosine of 45 plus the sine of 45 times the, 60 doesn't matter because of the commutative property of addition or multiplication, that I can multiply those in any order. To be consistent, I should have wrote it with the 60 first and the 45 second, so it would have been consistent with that model that we have. I could rewrite it, but I'm not going to take the time because we understand that my mistake, fortunately, is bank error in our favor. It doesn't matter in which direction I wrote that. I'll try to be better next time. So, all right, now here's what we need to figure out. This might be the hard part, unless we're starting to remember what some of these specific angles were. So what was the exact value of the cosine of 60? That was 1/2 times the cosine of 45. What was the exact value of the cosine of 45? That was a root 2 over a 2. Plus, I'm going to do the sine of 60 for, well, sine of 45. What's the sine of 45? It's also the same thing as the cosine of 45. And the sine of 60, that was a root 3 over a 2. Now again, these are the exact values of some angles that we've been practicing and using quite often. So we're beginning to commit those to memory. From here, it's just a matter of looking back at some of our college algebra days and adding through. So this becomes a root 2 over a 4, top times top, bottom times bottom, plus a root 6 over a 4. And then if I want to clean it on up, I can combine the fractions. So that becomes root 2 plus root 6 all over a 4. Now this example is just to help us understand that we can kind of look at backwards as well. So if I saw this, which I don't know why I would, but if I did, I notice that it's the right side of our equation or right side of our identity. And if I can recognize that, then I can move it back the other direction. Where I have, in this particular case, my alpha is 80 degrees, my beta is 20 degrees. So we can rewrite this then as the cosine of alpha minus beta, which in this case is 80 minus 20. That we know we can go ahead and reduce that. So that's a cosine of 60 degrees. And the cosine of 60 degrees, do we know the exact value of the cosine of 60? We do. That's 1/2. So maybe once in a while we want to be able to identify these identities from both sides of that equality sign. We can also verify some additional identities as well based on our new other identity that we were able to develop earlier. So I have the cosine of alpha minus beta all over sine alpha, cosine beta equals cotangent of alpha plus a tangent of beta. So how do we verify identities? Typically we work on one side, and we try to typically choose the side that looks a little bit more difficult as we can start to work our way through. The left side, I'm going to start there. It looks a little bit more difficult, but it also has this new difference angle involved as well. So maybe I need to learn it and go in that direction. So let's go ahead and just work on the left side. Cosine of alpha minus beta also equals to cosine alpha, cosine beta, plus sine alpha, sine beta, and that's all over the sine of alpha, cosine beta. All right, how are you guys feeling? So what should we do next? Okay, maybe we can do that. So let's try that. Let's go ahead and break this up into two separate fractions. So one, or the first one, would be the cosine of alpha, cosine of beta, all over sine alpha, cosine beta, plus sine alpha, sine beta, all over sine alpha, cosine beta. All right, I did that like you guys wanted. So what should we do next? Oh, okay. You're right. I do see some clever versions of ones or some terms that we can factor out. I have a cosine beta over a cosine beta. That's really just a 1, or they factor each other out. And I have a sine alpha and a sine beta over here too. So you're right. I guess I can just kind of bring those out. So all I have then is I have a cosine alpha over a sine alpha times 1 plus a sine beta all over a cosine beta. Okay, so what? Does that help us? Well, it helps us if we remember one of our fundamental identities. What is a cosine over a sine? That's cotangent. So cotangent of alpha, sine over a cosine is tangent. So I have tangent of beta. And that matches my right side. So therefore, identity verified.